Hello. Hello and welcome to the talk. Today we're going to talk about the top 7 tips for how to become a Microsoft Graph guru. We'll tell you about some basic stuff and some latest additions to the platform that will make you more productive as a developer on Microsoft Graph. This is supposed to be a 300, 400 level talk, so it's good if you're familiar with the Graph API already. But if you're new to it, we think that at least a few of those tips you'll find useful as well to get started. So quick introductions. My name is Peter Ciszewski. I'm a program manager working on Microsoft Graph. I work in the identity division where we develop products such as Azure Active Directory, but we also develop and maintain some of the core components powering the company-wide Microsoft Graph. Here with me is...
Yeah, so Jeremy Thake. I'm also in the Microsoft Graph team. I'm actually in the M365 core side of Microsoft Graph. So we kind of represent all of the API workloads that are on the Graph. I specifically personally focus on the developer experience in the Graph. And so a lot of the things we're showing today are from our team and Peter's team combined together to tell the story of Microsoft Graph. So a lot of the tips have come from looking at what we see on Stack Overflow as concerns and questions, as well as what we see in the support calls as well. So we really hope that this is going to help you to not fall in some of the traps that some other people have got into in the past. It's definitely helped with our roadmap and backlog from a developer experience perspective. And we have 45 minutes to get through 7 tips. So I'm going to hand straight to Peter to jump straight into it.
All right, so real quick, just to recap what Microsoft Graph is, it's a unified API surface that lets you interact with all the data and services in Microsoft 365. So if we look on this slide here at the bottom, you see all the different pieces of data, or we call them resources or entities. All of them exist in different services. Email messages will be in Exchange, files will be in OneDrive, users and groups in Azure AD. But the promise of Microsoft Graph API is that you don't have to really know all that. You interact with them as they are, and Graph takes care of routing all the calls to the correct services. The idea is that you can build your own experiences, such as the different types of apps listed there, that interact with these services. You can build an email client, a calendar scheduler, and so on. But you can also use Graph to introduce your own data into the 365 platform and enhance the existing experiences. You may have heard about search connectors, which allow you to upload external data and make it available through search for your users. The tips are mostly going to be focusing on building your own experiences aspect of Graph. So the first tip, whenever we talk about Graph, is usually about authentication. So you have to authenticate to access the APIs and to access the data. It's important that you choose the right authentication flow for that. And there are really, the top level choice is binary. Is your application going to interact with the data on behalf of a user or on its own? So the first option here, it's on behalf of the user. The application itself does not have the ability to call any APIs unless there's a user present and they sign in and they provide a token. Examples of apps you would develop that way, such email client, scheduling bot, a people picker. The other option is you want your application to run on its own. It might be a daemon service, a user provisioning workflow, or a system that scans all the incoming messages or outgoing messages for data loss prevention. Such an application needs to have its own set of secrets, typically a certificate, to authenticate, and it can operate on large scopes of data on its own. So a quick overview of what we call the user interactive scenario is, or sometimes we refer to it as delegated auth. A user must be present. It's typically the user or admin that consents to the permissions that the app requires. Once that happens, the app is able to obtain tokens on behalf of the user and use them for API calls. The key point here is that the effective permissions that the app has for a particular call are the intersection of what the user is allowed to do and what the application is requesting. So that means that if a powerful user logs into your app, they'll have access to more data. Maybe they'll be able to enumerate the entire directory of the company. But if a less powerful user logs into the same app, they'll be limited in terms of the data that will be returned. you're basically allowing the Microsoft 365 service perform proper authorization for the user because they see that user context in the token. So that's highly recommended when your scenarios are like that. Here's a real quick example of my app obtaining a token for Lydia and trying to access her mailbox. And we get a 200 and we can enumerate her emails. But if my app tried to use the same token and access Peter's mailbox, it would be the underlying service, Exchange Online in this case, rejecting that call because Exchange Online can perform authorization for Lydia's access to that particular mailbox. So your app would benefit from that. The non-interactive scenarios, there is no user present and the app has its own credentials. For those typically, or always, the administrator has to consent on behalf of the entire organization. The permissions typically are very wide, like reading all files in all SharePoint sites in the company, or reading all mailboxes in the company. So it's a very high level scope. Once that consent happens, the app can now obtain tokens on its own, and it has full permissions as described. There's no user in the picture here. Real quick, some good and bad design choices for the interactive case. Obviously, a simple one. Let's say we're building an email client. We're having the user sign in. We're calling Graph directly. That's fine. A lot of people want to introduce a middle tier to encapsulate their business logic between their end client and Graph. The flow we recommend is the on behalf of OAuth flow. Essentially, your email client gets a token for the middle tier, but when the middle tier wants to call Graph, it exchanges that token for another one. That new token, however, still contains the user context. So the same thing I showed you before, Exchange still knows it's that specific person calling. It's just going through the middle tier, so you're benefiting from proper authorization. A bad idea is to make the middle tier a non-interactive app, like I demonstrated just before, and have it make calls to Graph, essentially ignoring all the information about the user or not passing it on to Graph. In that case, that middle tier would have way more privilege than the user is supposed to have, and it would be up to you, the developer of the middle tier, to make sure you're not leaking information to the end user, like you're not allowing them to read other people's mailboxes. We don't recommend you be in that position ever. So use the user context in the token in that scenario. For non-interactive, it's typically very simple. Here we have a provisioning flow. It uses a certificate to authenticate, make calls to Graph. What we do not recommend is using or baking in actual user accounts, credentials, and having like a daemon app running in the background, maybe stuffing a password into the authentication flow. There are many things wrong with that. You're not benefiting from our tools for managing application secrets. You're also typically using, in this case, a very over-provisioned account. If that account leaks, terrible things might happen. So that's a quick overview of that. And let me do more of a hands-on tip and demo of how authentication actually works in code with Microsoft Graph. In the past, or currently, we give you two main libraries. You have Microsoft Authentication Library MSAL. That's how you manage your tokens, request tokens from the authentication service. And we're giving you Microsoft Graph SDK on all the different platforms to making requests to the API easier. Up until now, it was a little bit confusing how to integrate the two. I mean, it wasn't that difficult, but typically you would struggle for a little bit until you got it right. What we've done, we've extended Microsoft Graph SDKs with auth providers that wrap themselves around MSAL in a more friendly way. And so you're still using MSAL, which is our recommended library, but you're benefiting from the implementation of certain tricky scenarios, like incremental consent, conditional access challenges, and you're still benefiting from the SDK really playing nicely and requesting tokens only when it needs to and refreshing them for you. So let me do a quick demo here of what that looks like in practice. So we're going to do an interactive scenario first. I hope everybody can see. Does it look okay? All right. So here I'm creating what we call a public client application. As you see, I'm only feeding in the application ID. There are no secrets here because this app cannot do anything on its own. I'm specifying the minimum scopes or permissions that I need to run my scenario. That's useful for users who have not consented yet, as opposed to having them consent to all the permissions your app might have registered. This just says that's all I need, these two for now. And I'm creating an interactive authentication provider. That's the class from the new SDK extension. And as you see here, all I did was pass that auth provider to the graph service client, which is part of the SDK. And now I'm going to try to get some emails out of the mailbox. First thing I want to do is to get the user profile, so I'm saying .me. And what's interesting is that we have not seen any logon prompts yet, so nothing has happened authentication-wise. It's only when the Graph SDK is about to make a request, like right now, that it's going to invoke the provider and the MSOL library to get a token. So when I hit F5 here, it will prompt me to log in for the first time. That's all built in. I didn't have to write any of that code. So here we are. If you can see in the console, it's printed my display name. And now I'm trying to get the first email from my mailbox. As you see, there was no authentication prompt. It's reusing the same token between the requests. When the token is nearing expiry, it will renew it automatically. So now let's do something crazy and see if I can read other people's emails. So that was my what I demonstrated before, and I quickly get a 403 forbidden from the underlying service because it failed my authorization for that request. A non-interactive scenario, it's slightly more complicated to create the application. We have to specify the app ID, but also the tenant for which we'll be authenticating. And we need to feed the secret to authenticate. I'm using here a secret, a client credential, which is kind of like an application password. But in a production environment, I would use a certificate for stronger authentication. And I would really pay attention to managing that certificate correctly so it doesn't leak. And other people cannot use this application to access data. In this case, we get a token, and now we will be able to print other people's emails. So I just picked 5 top people in the organization and peeked at their mailbox because my app is permissioned for that sort of access. So I mentioned a few things that we've added to the SDK. Jeremy will walk you through some of the other improvements we've made.
Thanks, Peter. So I saw a few people in the front row with their laptop turned on, quickly scrambling to change the way they approach authorization in the Microsoft Graph. We've briefly gone through those. There's a lot of documentation that covers that a bit further. But one thing I wanted to highlight was who heard about the PowerShell APIs this week already at Ignite around Microsoft Graph? A fair few of you. I'm loving them already. Myself and Darryl have been kind of crashing away on a few modules that we've found quite useful. And one thing I found, even if it's just not resetting demos, but if you want to test as an end user that maybe you've been using for a while and clear out the consent experience that Peter saw, I have a demo here called Ignite 2019 demo. And if you go into Enterprise Apps, this is going to show you all the service principles. And you can go into here and you can see who in your organization has actually done user consent, so the flow that Peter did the first time. And I'm in a different tenant, but he's probably using Megan as well. And you can see here that Megan is the only person that has consented to this particular application. This is one benefit of kind of the traditional approach, non-auth, OAuth, where you use username and passwords. You can't get that kind of insight into who's using the APIs within your organization. So by using OAuth tokens and using this identity approach, we can go to that granularity and even revoke Megan's permissions. But that, as a developer, is a little bit slow to keep going back into this interface and click, click, click. And to remove that, essentially, you would go into properties here and click delete. With our new PowerShell LCAs, not my Visual Studio code, with the PowerShell SDKs, essentially I connect to the graph, I ask for directory read write all and directory access as user all, and I just go and find that particular application, and then I can actually go, and if it returns, remove that service principal and run that. So I just have a quick PowerShell core console up here that will run, and that will remove the fact that me as Megan has consented this app in the past. So it's a great tip if you're testing kind of consent flows and so forth within your application. So that was a sneaky tip that was kind of a 2.5. One thing you saw in Peter's app was this notion that he was try catching a service exception to understand what error had happened when, as and on behalf of user flow, went through trying to access Peter's inbox as a user that wasn't Peter. And we've done some great work in the SDK to make that exception handling a lot better for you as developers. One thing just to step back and talk about is we really prefer that you use the SDKs because we can help you along the way with some of the things like troubleshooting and service exceptions that you would have to hand roll yourself as a developer. We found so many companies we spoke to ended up almost building their own graph SDKs that was doing a lot of what our SDK did. They're all open source. We listen to the feedback, and over the last year, I hope you realize from the work that Daryl, who's a peer of mine on the PM team, has been working through the .NET, the JavaScript, the Java, and the Objective-C API SDKs, is that we've been listening and collating all that feedback. One of the benefits here is we update this every time the service updates. So every week when new metadata, new APIs appear on the graph, we will regenerate those SDKs and publish them wherever those packages are available on the internet. You don't have to use the entire stack of the SDK. What I'm going to demo today is essentially leveraging the entire part of the SDK. You can decide to cherry pick. If you're very comfortable with the HTTP client layer, you can use the MSAIL layer, you can use those all providers that Peter just talked about, and you might just stop at the HTTP and build your own requests. But you can also benefit from all the strongly typed objects and everything else inside that. And you can also extend the SDK. And we'll show you a little bit of that today. So one thing a lot of people don't realize is, and Peter obviously demonstrated the auth side of the benefits there in the Graph SDKs, but we also handle all the throttling, which Peter will talk about later on. And we also compress what you send over the wire to the graph, and then we uncompress what comes back over the wire from the graph for you for free. And we also handle things like the redirect handling that you would have to roll in yourself if you were just at the HTTP client layer. Now, naturally, we do allow you to use strongly typed objects too. So we will serialize and deserialize all those messages that come back from the graph. The main benefit there, for me as a lazy developer, is I'm going to get IntelliSense in my code. It makes it a lot easier to read. It also means if you have new developers that are familiar with SDK and they jump on your project, you're not having to teach them your custom SDK. They're going to know because they're going to be familiar with our standardized SDK that we use. And the benefit of this is also you get compile time feedback rather than at runtime feedback where you're crawling through the logs if you've made typos in maybe how you've tried to construct that graph URI. Now, there are some scenarios in the graph that are a little bit more complicated to put together as an HTTP request, like when you're trying to deal with batches, which I'll show you in a moment. But also things like if you're uploading a file to OneDrive that's over 4 megabytes, there is a little bit more of a sequence you have to do to upload that file using the graph. And so we provide that large upload file function within the SDK that kind of takes away some of that complexity from you so you don't have to worry about that and understand all the slicing it's doing under the covers to get that over the wire into our graph experience. So what I wanted to show you straight away was the error handlers. So if I go over to Visual Studio here, I'm hoping that's nice and large for you at the back of the room. I'll get a check from Yina. She's nodding. She's giving me the thumbs up. Thanks, Yina. And essentially, we have an application here that kind of extends what Peter was doing. I'm going to go get my profile information. I'm going to get some of my files, some of my events, and some of my messages. I'm just going to jump into this, this method here. And I've not quite finished my work. I'm going to go complete it here. So a quick question. How many of you use Graph Explorer in the room? How many of you have seen the new preview Graph Explorer? Lots of you. So my favorite new feature in Graph Explorer is I can still use the samples like I've done in the past to go get my mail here on the left-hand side in the samples, and it will return my response. But now if I go over to the snippets, I can really lazy dev, and it will give me the .NET code or the JavaScript code and even the really ugly Objective-C code that you might have to use as an iOS developer to render that to the screen. So lazy dev, I can come in here and copy that, paste that in. But one of the other tips we have from an error handling perspective is, how many of you use like some kind of correlation ID or some kind of tracking ID through all of the system to kind of then correlate in maybe App Insights or other places in code? Many of you? A few of you? So we have the idea to have what we call a client request ID. Now I've hard-coded this one for my hockey sample so that it's very obvious that it's going to work. And the only thing you have to do with that header options then is in your request object here is just add it in as part of your standard call. Now if I compile this code and run, again, it's going to be using that auth provider that we have within the Graph SDK. It'll pop me up a console application. And if you're using .NET Framework right now, you do get this nice pop-up window. If you're using .NET Core for now, it will give you the device code flow where you have to copy and paste the code in. And I'm going to sign in as Megan. Now, because I axed that application using my PowerShell script, it's telling me exactly the permissions I need to run this application. I'm going to accept those, and we're going to go through my code. Now, what you will see is that I've got an exception. If I go back into my console application here and just zoom in at the back here, maybe not that far, you'll see that I'm actually writing out some things. I'm writing out what the return status was. I'm actually returning the raw response as a JSON package here. So I can get in and start to see things like exactly what the error code was, and I can also get back my request ID. And you'll see that my baked-in client request ID is coming back too. Now, I've wrote this out to the console. You could ship this into a log, whatever iLogger you're using. You could also ship this straight into App Insights and allows you in every single environment to kind of use your own personal correlation token inside of whatever logging systems you're using to pull that through. We see a lot of our largest companies doing that, and they see real benefits. One other really cool tip with the SDK, if I just stop here and go into my function, is I could go and work out and put this in my web config or app settings of the permissions. My new second favorite thing in Graph Explorer is if I click the permissions at the top here, I can actually see what permissions I need to be able to do each method that I run in the Graph Explorer. That's pretty cool, right? How many of you guys have struggled in the past with permissions in Graph? Thank you very much. I didn't kind of have to pull that clap out of you too hard. I know it's late on a Wednesday. So I know that I need mail.read, and if I scroll up to the top here, being a demo thing, I've kind of hard-coded my scopes in the top, and I'm missing that. Now, you don't have to put that at the beginning of the app. Maybe there's only certain code flows in this console application that I need it. So I have the ability inside of here to go through and type a new string array here, and I can put mail.read in. Now, the benefit of doing this here rather than the top is that it doesn't have to Megan might not have to consent if the code flow never needed to access a particular function. Now, in this case, it always will. I've not done anything too complicated. But just to show you what that does when I run this up, essentially what that will do is it will already have consented to those ones I had hard-coded in the code. So I'm still going to have to log in as Megan once. Now, once it executes that code and it gets to that get messages function with the with scopes, in this case, it pops up again, and when I do this interactively with Megan, it'll now say, well, actually, this code flow asked me to do the read mail, and I can accept. So all that's built into the SDK without you need to do any clever kind of juggling in the underlying code. I see some nods, so I'm assuming that's a good tip that I've just showed right there. Okay. Now, we can take that further. So we talked about extensibility with the SDK. With the SDK, essentially, we have the ability to add middleware in the pipeline of the execution from where you kind of call the graph all the way down through the auth stack and in between. In my code, if I go at the top here, where we actually create the graph service client, you'll see that there's some new things that we're leveraging as part of the 1.119 edition of the Graph Explorer SDK. What I'm actually going to do is I'm going to use the new Graph Client Factory to go create me the default handlers. And by default, we give you the auth provider that Peter showed. We give you all the redirect handling, the retry handling to help you with throttling, as well as all that compression. Now, you can remove and delete handles, reorder them if you want to get at the response body without it being compressed, all that stuff you can do. And you can see here that with a simple line of code, I'm just adding a new graph trace handler directly in here. Now, what that will do is it'll then have a whole mechanism that is exactly the same mechanism that the Azure SDKs do as well. And so in my code, all I need to do now, I've added that handler, is for my application is add this listener. If I go over to the listener class, essentially, as I mentioned, it's doing the same thing the Azure SDK is doing. And what I do is I just ask it essentially to, I essentially ask it to look for particular things in the code. And in this case, I want to subscribe to when every time a graph call is started and when a graph call is stopped. I get back this payload with a request in it, or I get the payload with a response in it, and I can cast it to the particular strong types. And then, in this instance, I'm writing to a console, but again, you could write this out to whatever App Insights or any other iLogger implementation that you decide to use. I can do things like write out what the listener name is, the request method is, and if I get a status code like Peter had in his example and I had in mine, I can even do things like write out the entire error, which means that I'd be able to see that in App Insights without having to put try catches and so forth through my code. I actually find this super useful because the way I used to do this in the past was I would have Fiddler running my machine, which can cause all sorts of complications. This allows me that I can just go look in my logs in real time as I'm developing and see that traffic coming in and out through my SDK in a straightforward way. So the benefit of this now is if I sign back in as Megan, I've got all those consent things already there. You'll see that inside of the experience here, that it's logging these things. So for instance, it's showing me that that was the exact call that was made by the SDK I constructed in the .NET Poco types, and then this was the exact time it took on a stopwatch percentage of duration of kind of requesting that call. So there's some super useful things you can do here whilst you're developing, but also when you're in staging and pre-prod and production, that you can start looking in App Insights for things where maybe graph calls are taking too long and start to really optimize what's going in your code. So we've shipped those handlers as part of the SDKs now in .NET, and we'll be doing the same thing across those others as well inside of our experiences. So that was the middleware was tip 4, and then tip 5. We hear a lot of feedback from customers around things with performance around the graph. And what guidance we give to our customers is essentially that the fewer requests you throw over the wire, the more optimized you can be as a customer. And the benefit of that is there's less traffic kind of hopping over and going through switches and routers and going over to our cloud and then coming back again. One thing that we noticed is that with the batching capabilities we've had on the graph for a while now, if you can package those requests up, and you can do that in basically batches of 20 requests, and send that to us as one network call rather than 20, we have a lot of efficiencies. Now, one thing to bear in mind with this particular mechanism is that when you do that 20, they can't be kind of chained together. So I can't throw a get me my messages and then say get me the attachments of those messages. You would have to do that in 2 separate network calls. There's no intelligence in the call, so they have to be totally isolated. Now, one example of this is, say for instance, you wanted to add licenses to a particular set of users within your organization. Hypothetically, let's say we have 1,000 users. When you run this without batching, essentially you're making 1,000 calls to the graph. That will typically take around 4 minutes to do, and it will take 1,000 calls to run. Now, if I started batching those 1,000 calls down into 20 call batches, I essentially reduce the amount of calls I have to do down to 50. And now, rather than 1,000 users to add that license to in the graph, taking that 4 minutes, it's actually only taking 12 seconds because the fact you're reducing that via all those calls. So batching can really improve scenarios where you're trying to do a lot of things at once on a graph. So to show that in action, this is something that we shipped in 1.118 of the SDK. If I go over to my other file here, and I have a look at the batch calls method, what you'll see here is that we have this nice new functionality to go create a batch request. I can come in here, and for each thing I want to call, whether it's going to get me, or going to get events, or going to get my messages, I'm just adding those things as a batch request step. Now, the key here is for each one of these steps we add, we return a unique GUID ID. And the reason we do that is that once we have sent that batch over in this request, we return this response. And the way that you fetch out the different responses that come back for every step in that batch that you put through, is we uniquely use those IDs. And this allows you to cast it back to whatever strongly typed object that particular request was. So in this case, the whack me is going to user, and that way I get a nice strongly typed user object, and I can do things like .surname and get the surname of the user. And then if I want to iterate through all the events that come from my calendar, I can just happily render those to the screen and render out those subjects. So we've improved this based on your feedback on, we had some batching in there, but we've definitely made this better with the way that you can handle this with GUIDs and handle those things. And so if I was to run that, that would basically do exactly the same code, but it would have done it in one network traffic call over the wire and come back, and you'd be able to break that up and do the same effect. That, in this instance with this particular sample, is about the same time. But obviously at scale, if you're doing batches of 20 and you're iterating through lots of different things, you can get really good optimizations there. So Peter, to hand it back to you, we have to be careful with batching, right? It's not going to save some of the issues that we've heard about in the past around throttling and other aspects because of the nature of how batching works.
Yes, every time we try to put a lot of load on our service.
We'll go from my computer because I've just broken this horribly. There you go. You just tap the keyboard and I'll transition.
All right.
I'll be your PowerPoint dummy.
We have to worry a little bit about throttling, and whether that's because we're doing optimizations like Jeremy alluded to with batching and parallelization, or whether our application is getting adoption with a lot of users. We should expect that at one point, like any other web service, Graph will start throttling us, or as we say sometimes, rate limiting. The way you typically handle that is you expect those two status codes. 429 is the error code telling you that you're exceeding your quotas. So that's a hint to you that maybe you should be doing something differently, maybe you should optimize your app, or at least you should understand the calling patterns that your app is making. 503 is more of the service protecting itself from overall load. So it's not necessarily you, but the service is just not in a good shape, and it started rejecting calls. So you should still handle it, but there isn't typically much you can do about it in terms of your app redesign. Both of these include a retry after header that tells you how long you should wait, and you should really obey that value there before you retry. The good news is in the Graph SDKs in the new version, we're now shipping default error handlers for this. So out of the box, you'll get retries for throttling. I'll show it in a demo later. We do strongly recommend that you log in your telemetry the cases of throttling, because this is typically how you will learn about the problems your app is experiencing and how you need to optimize it. Typically, those things do not come up in testing. So an important tip, and also related to batching, individual requests in a batch fail individually. So if I submit a batch of 20 requests, almost in all cases, the batch itself succeeds with a 200, but individual requests might fail, like we may get a 404 if a mailbox doesn't exist. If you think about throttling, it's almost certain that your batch will get throttled partially. Like statistically, out of your 20 requests, a few will go through, and then the service will start rejecting. So it's very important that you handle them individually, and then you retry only the ones that failed. We often hear from our customers and developers, why are we not explaining throttling limits that well? Why don't we just document how many calls you can make to Microsoft Graph? And the truth is that Microsoft Graph is a multi-layered system, and each layer is a service architected very differently from other services, and they all have different structure and different reasons for throttling. This is why it's very hard for us to say this is how many calls you can make to Graph. There are certain limits at the very top for the gateway that limit how many times an application can call, but you typically won't hit those. Typically, as your call traverses into, let's say, Exchange, you'll start experiencing Exchange's throttling behavior. Exchange has some specific connection limits, for example, that you cannot have more than a certain number of concurrent connections to a mailbox. That's unique to Exchange. Azure AD looks at app and tenant quotas, and it categorizes tenants into different sizes and is more generous for large ones and less generous for smaller ones. It has API-specific limits that vary greatly from a few seconds to a couple of minutes. And is very sensitive to writes, so write limits are typically very low. SharePoint has its own resource-based and scenario-based approach to throttling. So what we're trying to do is we're going to get better at documenting these individual service limits, but we won't be able to give you like a high up number. In the end, you'll have to really think about what your app is doing to and experiment with it a little bit to learn how throttling impacts you. Here's a quick case study of that I did last Ignite as well about what that experimentation may look like. So in my scenario, I was trying to add 100 users to 100 groups, so roughly 10,000, well, exactly 10,000 write operations against Azure Active Directory. And I was trying to squeeze all the performance I could out of Graph using parallel streams and batching. So in the first row of the table, you'll see that I threw 6.6 thousand requests every minute. So I was very happy that I managed to do that, and all my requests completed in 1.5 minutes. However, the total execution time was 9 minutes, and that's because Azure AD punished me severely for being so aggressive, and it throttled me 3 times, 2.5 minutes each. So my app said doing nothing for 7.5 minutes. So then I figured out that as I scale down, somewhere down there around 2 parallel streams and 2,000 requests per minute, I get the optimal execution time. So this is a very simple case, but it points to the fact that it's not obvious what is the best, most optimal way of calling. And you have to learn that through practice and then adjust as you go. We often hear from developers in the context of throttling as well as in general, how do I test error handling in my app? How do I make sure that my app does respond to throttling correctly or other types of errors? So we've done something cool in the Graph SDKs. We've made fault injection quite simple, and I'll demo this in a second. You can now simulate failures without modifying any production code almost and not writing specialized tests. You can configure the type of failures you want to experience, and we have this class called Chaos Handler that's part of the middleware that Jeremy was talking about. So you set that up, and then when you write your code against the SDK, you get kind of fault injection all over the place. So let me do a quick demo of that. Very simple scenario here. I'm creating an auth provider for my application. I am creating a Graph client, and first we're going to try it very basic stuff. So I'm using the same trace handler that Jeremy was showing just to be cool. And my goal is to enumerate all the users in the company. I'm doing it in pages of 5 just to generate more pages. And let's see what happens. I just power through this. You see pages of 5 users each, and nothing bad happened. Let's say my goal is to see what would happen if my application started experiencing throttling. Will it work? So all I have to do, I'm not touching any code other than my initialization of the Graph service client. And I'm adding an additional handler, which is the chaos handler. If I go to the method that sets it up, you'll see it's very basic. I'm saying 20% of the time I want to experience chaos, and this is the type of chaos that I want to experience. So I'm setting up 429, that these are built-in helper methods. throttling responses and service unavailable responses. I can customize how long they should delay me and so on.
And this actually came from a request in the MVP Summit, and I forget who suggested that we should call this the Chaos Giraffe Handler, like our giraffe mascot, as opposed to the Chaos Monkey Handler. But the SDKs, we decided to be a little bit more straight down the line and just call it the Chaos Handler for being strict.
So I still have exactly the same production code other than the initialization here. So let's run that. And you see those blue lines. I experienced a 429 response. Then I got a few pages, no problem. Then I got a service unavailable and so on. So this is randomly injecting error responses. So what I've learned here is that somehow my application is handling these, and I'm not sure how, because if you look at my code, there's no code here retrying anything. So the answer is that I'm benefiting from the middleware that's by default added to the graph client that retries these errors. Let's say that I didn't like that retry behavior. I didn't like the fact that I was retrying everything. All I need to do as an additional step in the initialization here is to replace the retry handler with my own. So again, very simple code. Essentially what I'm doing is I'm taking the original should retry method that's baked into the SDK, and I am replacing it with my own logic, which in this case says, if I see 429, I want to fail. I don't want to retry. Because my goal is to test what happens if I did not handle throttling. But if it's a different error, then I'm just reusing the default logic. So all I had to was to write this simple method here. So now let's run. And if we're lucky and we get a 429, we should get a...
Because it is random.
We should get an exception on that account. There you go. So same code, same everything, but this time we have an unhandled exception due to a 429 error. So this just gives you an idea how you can use the SDKs to make your life easier, how you can use the new middleware architecture to plug in your own behavior. Obviously, that chaos handler could be used to simulate other errors, 404s, whatever you want. You can imagine, configuring your service clients differently in different parts of your code, and then have a configuration that you control, and you can dial up and down the different failure configs. And then when you go to production, you just remove turn that all off, and you have production code. So, Jeremy, why don't you walk us out of here?
Yeah, I guess the thing to take away here is that we're really trying to encourage you to help us, to help yourselves with feedback around what you think of these SDKs as we're evolving them, as we're adding these handlers, as we're improving the customizations that are available within those handlers, like the retry handlers. We really want to hear back on some of those scenarios about what you're using, what you'd like to see. We have a good, avid community that's helping to build some of these retry handlers. Paul Schäflein, for instance, who's the co-host of my podcast, was the one that helped write the graph trace handler there as an example of something he was doing in a real-world scenario with his customers. So just want to say thanks to Paul as being part of this demo, and also to a lot of other people here I see in the room that are contributing back to these GitHub repositories. So just to close out, if you are not familiar, we actually do have Microsoft 365 developer training available that we've just launched this week. One of those modules is actually a module specifically on throttling. And so it explains to you with the hands-on labs of what types of things you can do to try and trigger that throttling and how you can handle that both in your own code but also by leveraging the SDK. We have got a deal on at the moment through Microsoft Learn that means that for anyone that is an Ignite attendee, they get 80% off the beta period of the cost of the exam if you go and take all those modules and you want to become a Microsoft 365 certified developer. So I'd encourage you to go and check that out. It's a great way of just testing whether you know the whole surface of Microsoft 365 development, including the Microsoft Graph. And also, we've had a lot of questions this week in the booths around, hey, look, I'm not able to test certain parts of the Microsoft Graph because my company has blocked particular permission scopes without having to go to IT to get them approved. If you join the Microsoft Developer Program, you can actually go sign up for that. If you go to graph.microsoft.com, in the top right on the navigation, there's a dev program link under resources. They will give you a free Office 365 tenant. That demo I did there was using one of those that was provided to me via the developer program. You get a bunch of users so you can test scenarios where maybe you're Megan one day and you're Nesta the next, and then you're whoever else are the fun names that come up in these environments. It allows you to test these scenarios where you can test consent and test the least privileged permissions that you need for your application before you go deploy that into your internal IT environment. So I'd highly encourage you to go check out that dev program. It's a great value, and it's not just the environments you get there. There's a lot of content that we provide there too. So with that, thank you, Peter, for sharing the stage with me today and sharing those tips. We would love to hear feedback from you on in this session, things on your mobile phones, on the websites as well for Ignite. Were the tips useful? Was the breakdown in this session useful, and the pace of it and the depth of it? We'd love to hear that. I'm hoping the room was nice and cool for you. We've had some rough feedback on rooms being warm. There's nothing that me and Peter can do about how hot or cold you are in these rooms. And so enjoy the rest of Ignite. We will be down in the expo hall for the rest of the week if you have further questions, and enjoy the rest of your day and tomorrow and the theme park on Thursday. So thank you.
Thank you.